introduction over here. We are going to out the letters कि ये कौन-कौन से letters हम इन compounds को दे सकते हैं. So we have done this that अगर आपके पास acidified potassium dichromate हो, it is actually K2Cr2O7 and it is changing its color. It is from orange to green. It is always going to change its color from orange to green and it is one of the oxidizing agent. So ये तभी change कर सकता है जब वो substance इसके साथ हो, use जो हो रहा हो वो oxidize हो जाए. So we know that alcohol can oxidize to aldehyde and carboxylic acid if you have primary alcohol, and if you have secondary alcohol, so it can be oxidized to ketone, and if you have aldehyde, so it can be oxidized to carboxylic acid. So A, B, and C, if these three can oxidize, so definitely if you are using oxidizing agent along with this, so it will definitely change its color to green. You need to keep remember that in this chromium has a +6 oxidation state, and when it changes its color to green, it will have +3 oxidation state. Then acidified potassium magnate is using ethanoic acid is actually obtained on boiling. So what is the substance जो कि ये cause कर रहा है? So you can see this, we have ethanol. So when you use any oxidizing agent and you are going to oxidize it further, so it is going to convert into ethanoic acid because it has 2 carbons, and also you have carbon-carbon double bond over here. So when you are boiling it with potassium magnate, that means you are providing hot conditions to this, definitely it will break. और जब ये break होगा, so you can see this कि यहाँ पर आपके पास CH3 मौजूद है और क्या क्या मौजूद है, आपके पास एक H मौजूद है. जब ये break होगा तो यहाँ पर O लग सकता है और यहाँ पर भी O लग सकता है, तो it is also going to form ethanoic acid. So C and E, they both are going to produce ethanoic acid when we use KMnO4 on heating. Then hydrogen in the presence of platinum catalyst, and you can even use nickel catalyst over here as well. And we know that this is one of the property of alkenes. When we react them with hydrogen in the presence of nickel catalyst, they react to form alkanes. So the only possibility for this is E. Then Falling's reagent. Falling's reagent is only applicable for aldehydes. So the right answer is C only. Then 2,4 dinitrophenylhydrazine DNPH. DNPH is applicable for both the compounds that have carbonyl group, C double bond O, ketone or aldehyde. दोनों के लिए useful हो सकता है. So it should be C and D. They both are carbonyl compounds. Then bromine in an inert solvent, यानी कि सिर्फ bromine है, सिर्फ bromine. So सिर्फ bromine dechlorize या reaction कर सकती है alkene से. So it should be E only. Is that right, every one of you?
Yes, sir.
Any problem to any one of you? So you can ask. मेरे ख्याल से यहाँ पर सब कुछ ही फैलिंग टेस्ट काफी आसान है, डाइनाइट्रोफिनाइल हाइड्रोजन काफी आसान है, ब्रोमीन टेस्ट काफी आसान है, हाइड्रोजन वाला रिएक्शन काफी आसान है. मेरे ख्याल से जो प्रॉब्लम हो सकती है वो फर्स्ट और 2 में आ सकती है आपके पास. जो पहला और जो दूसरा वाला ये थोड़ा सा टिपिकल थे, उसमें शायद आप लोग मिस्टेक कर सकते थे. अदरवाइज तो बाकी आप उसमें से भी आप बहुत सारे आंसर सही लिखते हैं मेरे ख्याल से. तो यहाँ टोटल आपके पास 1 2 3 4 5 6 7 8 9 10 letters आपको लिखने थे, and you got 9 marks over there, and it's quite simple question. और इसमें से 5 से 6 marks तो हर बंदा ले ही सकता है easily. ठीक है. So let's talk about next question. चलें तो next question करते हैं. और so if you want to draw a primary alcohol again, and what is the thing over here? You need to draw primary alcohol again, and it should be the isomer. Isomer means it should have the same molecular formula, but a different structure, right? So again, it's simple. Primary alcohol is one of the alcohol in which the carbon attached with OH should have 2 H's. So this is the primary one, and over here we have carbon chain. So एक तो straight chain हो सकती है, और straight chain के अलावा आपके पास क्या हो सकता है? Branch वाला हो सकता है. तो I am just drawing a branch one. 1 2 3, and over here we have 1. So I am now completing the hydrogens over here. Carbon needs to complete all 4 bonds, so it will be like this, right? So this is one more structure that is having C5 H11 and OH. So this is the branch structure, right, बच्चों?
Yes, sir.
And then in the next one, they are saying write a balanced equation for the formation or the preparation of 1-bromopentane from pentane, 1-ol. So this is pentane 1-ol, C5H11OH, and we want what? We want bromopentane. So it should be C5H11Br. This is nucleophile substitution reaction. We actually need to substitute OH by Br, right? And we know that for this purpose, we can simply use HBr gas or concentrated HBr, which will form one more product along with this is water molecule, right, Bacho?
Yes, sir.
And the third one, the B part 2, sorry, they are asking for the formation, something like a calculation type question. So simple, you can simple use, they are asking for what? This preparation gives a yield of 60%, right? And calculate the mass of pentane 1-ol, pentane 1-ol. They are asking for this, the mass of this required to produce 15 gram of this, all right? They're asking to produce 15 gram of this, and they're asking for the mass required of pentanol. So you can see this, they gave you mass and they're asking for mass. This is mass to mass relation. Whenever they give you mass and they ask you for the mass, so you can directly apply a relation. You can directly apply a relation, ठीक है ना? Mass to mass relation आप apply कर सकते हैं. And for this, we can use molecular mass, right? So you can see this, it is what, 5 carbons. So each carbon having 12 mass, so it will be 60, right? It will be 60 plus 11 plus 16 plus 1. So what is the mass of this? It is actually 88 grams. So you can say that 88 grams pentanol produces C560 plus 11 plus it is, I think, 81 or 80 somewhere. So let me consider 81 over here. 81 आप इसको कंसीडर कर सकते हैं, आप इसको 80 कंसीडर कर लें. आई थिंक वो एवरेज वाला कंसीडर कर लेते हैं. एवरेज वाला कंसीडर किया तो टोटल कितना हो गया? 60 and 80, 140, 151. So you can see this, that according to the equation is saying that if you have 88 grams of pentanol, so it would produce 151 grams of bromopentane, right? So इसको हम पहले unitary method में convert कर लेंगे. Unitary method मतलब for 1. So if it would be 1 gram, तो आपके पास कितना होगा alcohol use? It should be 88 over 151. इतना यूज होगा. पहले इसको यूनिटरी मेथड पे कन्वर्ट कर लें और उसके बाद आपको जो चाहिए फिर आप कर सकते हैं. जितना भी आपको चाहिए आप इसको कन्वर्ट कर सकते हैं. अभी हमें चाहिए कितने के लिए? हमें चाहिए ये 15 के लिए, और ये हमें चाहिए कितना परसेंट? 60%. ये हमें चाहिए कितना? 60%. So we will send 100 over here and 60 over there. So it will be like this, 88 over 151 into 15 into 100 over 60. So we can find out the mass required for this, right? So it will be like, let me do this. It is 88 into 15 into 100, and then divided by 60, and then divided by 151. So it is somewhere 14.569. It is somewhere 14.569. 14.569. So you can consider this 14.6 grams. Right, Bacho? Is it clear? Right, everyone?
Yes, sir.
Yes, sir.
Then in the next one, you can see this, that the dehydration of pentane 1-ol produces pent-1-ene. Sketch on the diagram below the orbital overlap between the 2 carbon atoms. So first of all, we know that they have carbon-carbon single bond, which is a sigma bond. And if you talk about the pi bond over there, so the pi bond is always, it always from over here like this. The p electron is free for the both of the carbon. So they will start sharing electrons like this. So this will be the pi bond form over there like this, right? So you can draw pi bond over here. This is all-time favorite question. ये बहुत आता है पेपर में. इस तरह की ड्राइंग ये पेपर में बहुत ज्यादा पूछते हैं. Is that right, बच्चों?
Sir,
जी बेटे,
how will we label them?
which one? You need to label
All
the
the
bond.
bonds.
Yes, you need to label the bond. So it is a pi bond. This one is a pi bond. It can be shown like this. And this one is a sigma bond. Sigma bond is always like this. And the all bonds are sigma bonds. Whenever the bond is single, so it is always a sigma bond. And the pi bond is always when जब एक bond के बाद double bond बनता है, तो जो double bond होता है वो pi bond होता है, जो triple bond होता है वो pi bond होता है. Single bonds हमेशा sigma bonds होते हैं. ठीक है? ठीक
Yes,
है?
sir.
Okay, so let's move on towards the next part of this question. So what is this saying? You can see this. The two compounds below are among many secreted by the insects to attract members of the same species. And such compounds are used in traps to control insects population. They need to be made synthetically, right? For each synthesis, outline how they could be prepared from pentane 1-ol, giving the necessary reagents and the conditions, and it's for 4 marks. Again, you can see this, that you have pentane 1-ol and you need to form pentanoic acid by this. So it's very simple. What we need to do, bacho?
Acidified potassium dichromate.
And along with which conditions?
Hot conditions.
No, we need to do heat under reflux. It's very important to keep remember whenever you have a carboxylic acid along with alcohol, यानी कि alcohol से अगर carboxylic acid बन रहा है, so the condition is heat under reflux. And if you are forming aldehyde from alcohol, so it should be heat and distill. ये condition बहुत important है. ये difference आपने याद रखना है. ठीक है? So you need to say that if you want to use reagent, so it should be acidified potassium magnate 7, and the condition should be heat under reflux. It should be heat under reflux, right? So it would be like this. If you have CH3, CH2, 3, H2OH. If you want to form CH3, CH2 twice COOH by this, it would definitely form water molecule as well. And you use oxygen in this way because we are using camphor over here, right? And it is acidified. Okay, then in the next one, they are forming what? CH3, CO2, CH2, 4, and CH3. Yani ke they are forming ester over here, right? If you just break this bond, so it is saying that you are using pentane 1-ol along with ethanoic acid. So you can say that the reagent is sulfuric acid over here. You need to use concentrated sulfuric acid along with plus ethanoic acid. You need to use ethanoic acid as well. And what is the condition for this? Again, you need to heat under reflux, or you can say that heat up to 60 degrees Celsius, right? And what happened when you use C5H11OH along with C2H4O2, it would give you what? CH3, CO2, CH24, CH3 along with the water molecule. Right, bacho? Right, every one of you?
Yes, sir.
Okay. So let's talk about something different. Okay, so over here, they are saying that the question is about esters, and the ester occur naturally, and we are widely use this. In the box below, draw the structure formula of any 3 different esters that have the molecular formula of this C5H10O2. So that's fine. You can draw like this: 1 carbon, 2 carbon, and 3rd carbon. And the 3rd carbon you can form a ester linkage, and then these 2 carbon. In this way, you can form what? One of the ester. And what is the name of this? It is ethyl propanoate. It is ethyl propanoate, right? You can even draw like this: 1 ester linkage, and like CH3 over here, and then we have the rest of the carbon on this side, right? So it should be what? It should be methyl butanoate, right? And even you can draw like this कि आप जो है एक भी हाइड्रोजन उस तरफ ना करें और या एक हाइड्रोजन इस तरफ कर दें, for suppose like this, and the rest of all 4 carbons should be over there. So it will be what? Sorry, एक कार्बन तो यूज कर लिया ना हमने. So it is like this. तो इसका नाम क्या हो जाएगा आपके पास? It is butyl methanoate, right? So इस तरह आप बना सकते हैं या इसके अलावा आप ब्रांच भी लगा सकते हैं if you want to make a branch. So आप ब्रांच भी लगा सकते हैं. ब्रांच कैसे लगाएंगे कि ये हो गया H C डबल बॉन्ड O और ये हो गया एस्टर लिंकेज 1 2 3 कार्बन और इस पे आप ब्रांच लगा दें like this और फिर उनके हाइड्रोजन्स कंप्लीट कर दें. So you can even draw a structure like this. इस तरह का भी स्ट्रक्चर आप बना सकते हैं. कोई से भी 3 बनाने हैं. उसने हमें स्ट्रिक नहीं किया कि हमें ब्रांच वाले बनाने हैं या बगैर ब्रांच वाले बनाने हैं. जी बेटे.
सर इंस्टेड ऑफ ड्राइंग इंडिविजुअल ब्रांचेस के हम लोग ऐसे लिख सकते हैं, फॉर एग्जांपल C4H11 डायरेक्टली O के साथ बॉन्ड कर.
C4H11 यार C4H11 अगर आप लिखना चाहते हो तो उसने हमें बोला है स्ट्रक्चरल फॉर्मूला. तो जो C4H11 लिखोगे वो तो मॉलिक्यूलर हो जाएगा ना.
ओके
तो आप स्ट्रक्चरल फॉर्मूले की फॉर्म में लिखो, चाहे आप कंडेंस फॉर्म में लिखो, चाहे आप स्केलेटल में लिखो, चाहे आप डिस्प्लेड में लिखो, बट आप स्ट्रक्चर लिखो, मॉलिक्यूलर फॉर्म में ना लिखो. ठीक है.
ओके.
Then next one is saying write an equation for the hydrolysis of one of these esters. इसमें से कोई सी भी एस्टर्स की आप हाइड्रोलिसिस कर दें, इसको हाइड्रोलिसिस करके दिखा दें और आप क्या यूज करेंगे हाइड्रोलिसिस में? सोडियम हाइड्रोक्साइड, यानी कि जो आपके पास कार्बोक्सिलिक एसिड बनेगा उसका फिर सॉल्ट बनना चाहिए. सो फॉर सपोज आई एम सेलेक्टिंग द सेकंड वन. सो अगर ये बॉन्ड टूटेगा तो आपके पास क्या बनेगा भाई? आपके पास है CH3 CH2 CH2 CO2 CH3, ये आपके पास है. अगर आप इसके अंदर क्या डालते हैं NaOH डालते हैं तो डेफिनेटली आपके पास ये क्या करेगा? इस वाले बॉन्ड को ब्रेक करेगा. जब ये वाला बॉन्ड ब्रेक होगा तो आपके पास क्या बनेगा? एक तो आपके पास मिथानॉल बनेगा और एक आपके पास बनेगा ब्यूटानोइक एसिड. तो जो ब्यूटानोइक एसिड है वो आपके पास क्या बनाएगा? वो सॉल्ट बना लेगा. राइट बच्चों? राइट.
यस.
So this salt is very important over here. ये salt आपको लाजमी बना के दिखाना है. वहाँ Na लगाना जरूरी है, इसलिए उसने मेंशन किया है कि आप Na यूज कर रहे हो, सोडियम हाइड्रोक्साइड यूज कर रहे हो. ठीक है. Then I told you some physical properties of esters as well, that they are volatile liquids, they are insoluble in water, they are volatile liquids, or they are insoluble in water. So you can say that they are immiscible in water, right? You can say that they are immiscible in water, right? क्या कह सकते हैं आप उनको? immiscible कह लें या आपकी मर्जी, आप insoluble लिख लें, आपकी मर्जी है, आप जो भी लिखना चाहें. immiscible in water भी लिख सकते हैं, insoluble in water भी लिख सकते हैं, they have a specific smell, वो भी लिख सकते हैं आप. तो इनमें से कोई सी भी 2 लिख सकते हैं आप. ठीक है. commercial use you can say that. जी बेटे.
सर हम लोग ये लिख सकते हैं, they are sweet smelling liquids.
Sweet smell, you can say that they have sweet smell, right? It is one of the physical properties.
Sir.
It is used in the formation of perfumes. You can say that to make soaps as well. It can use even flavoring agent and different types of industries में ये अलग-अलग तरीके से use होती है. कुछ कह रहे हो समझ?
No sir.
हाँ ठीक है. तो इस तरह से आप इसके uses वगैरह भी लिख सकते हो. Any problem in this question बच्चों? होपफुली आप लोगों के आंसर इसी से मिलते जुलते आ रहे होंगे. अगर आपको कोई प्रॉब्लम आ रहा है इस आंसर में तो आप मुझे बता सकते हो. तो मैं आपको, for suppose we have this question now, how can we solve this question? They are saying that some perfumes and scents of flower and fruits contain compounds which are structural isomers. 2 such examples are citronellol and granulol, right? confirm that citronellol and granule are isomers by calculating their molecular formula and their relative molecular masses, right? What is the relative molecular formula? So for this, we just need to calculate the number of carbons first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So actually we have 10 carbon, right? And then hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, and then 20 hydrogens. And we have 1 oxygen as well. तो बच्चों यही आंसर आ रहा है आप सबका C10, H20 और O, या मैंने गलत कर दिया है? ये
Yes,
आंसर आ
sir.
रहा है? यही आंसर आ रहा है आप लोगों का, गुड हो गया. Then what is the molecular mass? So it should be 12 into 10. It should be 120 plus 20 plus 16 will give you 156, right? यही आ रहा है?
Yes, sir.
Okay. Then name 2 functional groups present in both molecules. Name 2 functional groups present in both molecules. So for this, you need to see that we have alkene functional group over here, right? And one is alcohol, right, bacho?
Yes, sir.
But can you focus over here that they are asking for both molecules 2 functional groups. They are asking for 2 functional groups and they are giving you 3 marks for this. Can you please see this? कि यार वो आपसे 2 functional groups पूछ रहा है and they are giving you 3 marks for this. So you need to keep remember that all the time, whenever they ask for the functional groups, and if the alcohol functional group is present over there, so it's mandatory for us to define the type of that alcohol, कि वो primary है, secondary है या tertiary है, ठीक है ना? So it is actually primary alcohol. So 1 mark आपको primary बताने का मिलेगा और 1 mark आपको alcohol बताने का मिलेगा. So you need to keep remember this, right, बच्चों? So this is primary alcohol because on the carbon where OH is present, we have 2 different hydrogens as well, right, bachcho?
Yes, sir.
Yes. Then they are saying on the diagram of the structure of citronellol above, draw a circle around a chiral carbon atom. Around a chiral carbon atom. So for this, we must need to remove these all kinds of things that over there. Yes, bete.
Sir, it would be the third carbon from the left side, right?
From the left side, it should be the third one. Let me check. You are saying this carbon, right?
Yes, sir.
And it's absolutely right because you can see this, that it has 1 hydrogen, it has 1 CH3, and it has this one as well. Nah? This one is something different, C2H4OH, and then C6 and these blah, blah, blah. So all 4 sides are 4 different types of species or the substances attached with this carbon. So this is chiral center. Absolutely right. Good job. Then what is the next part? If you see the next part, so the next part is saying draw other cis-trans isomers of granule in part D and F. Just look at over there. This is the structure, and they are saying that you need to draw the cis and trans structure of this. And it's quite difficult for me to draw because the space where I need to draw is different and the question is different. So how can we solve this? Let me try. Let me have a picture of this first. Okay. So let's do this. अच्छा देखिए मैं इस D part को यहाँ solve कर देता हूँ. They are going to ask about cis and trans isomers of granule. This is granule and they're asking for cis and trans structure of this ना. इसका cis and trans ये मांग रहे हैं तो मैं इसको यहीं बना देता हूँ, ठीक है? इसको मैं किस तरह बना रहा हूँ बच्चों? Just look at over there. ये जो मैं सपोज कर रहा हूँ इस डायग्राम को, इसको मैं सिस सपोज कर रहा हूँ. जैसे फॉर सपोज ये एक चेन यहाँ पर, एक चेन यहाँ पर है और ये बिल्कुल अलग चीज है. तो इसको अगर मैं सपोज करूँ सिस, तो इसका मैं ट्रांस अपोजिट डायरेक्शन में बनाकर कर सकता हूँ. कैसे कर सकता हूँ मैं इसको कंसीडर कर सकता हूँ ऐसे. देखें फॉर सपोज ये 2 कार्बन है जिसके दरमियान कार्बन कार्बन डबल बॉन्ड है. ये इतनी बड़ी चेन को मैं आर सपोज कर रहा हूँ, सिंपल अल्काइल चेन ना, ताकि ये मेरे लिए आसान हो जाए. और फिर ये आपके पास CH3 लगा हुआ है and then we have H, and then we have CH2OH. This is one of the structure. एक स्ट्रक्चर आपके पास ये है. दूसरा स्ट्रक्चर हम क्या कर सकते हैं, हम इन दोनों को एक तरफ कर सकते हैं. कैसे कर सकते हैं एक तरफ भाई? एक तरफ हम कोशिश करते हैं इस तरह करने की कि हम इसको अपोजिट डायरेक्शन में कर देते हैं इस तरह से. C डबल बॉन्ड C, CH2OH को मैं ऊपर कर देता हूँ, CH3 को मैं यहाँ नीचे कर देता हूँ. ये R अपनी जगह है, H यहाँ नीचे आएगा. So this is, you can say that in the same direction, so they are cis, and they are in the opposite direction, so they are trans. Right, बच्चों?
Yes, sir.
Okay, then the next part of this question is saying that explain why granule has no optical isomers. That's quite simple. If any substance have no optical isomers, it means it has no chiral carbon. So you can simply say that it does not have chiral carbon. It does not have chiral carbon. राइट बच्चों, उसके पास chiral कार्बन नहीं होगा, इस वजह से वो जो है आपके पास नहीं शो कर रहा होगा. क्या वो आपको शो नहीं कर रहा होगा ऑप्टिकल आइसोमर्स, राइट?
Yes, sir.
And it is up for 2 marks, so definitely ये definition जो आपने reason लिखा है ये 1 mark का, और ये जो आपने diagram बनाई होगी it would be of the 2nd mark. Then they are in the E part, they are saying state what you would expect to see if citronenol was reacted with aqueous bromine. So we know that both of the compounds having a carbon-carbon double bond. So whenever they react with aqueous bromine, so definitely they will dechlorize bromine. So you can say that bromine dechlorize, or you can even say that the brown color of bromine dechlorize, right? Then we have different structures over here, and they are saying that if hydrogen is added over there in acidified potassium dichromate heat under reflux के साथ अगर आप उसमें add करें तो क्या होना चाहिए? And we know that potassium dichromate is an oxidizing agent, so whenever you use this along with acidified conditions, so it's definitely going to produce, we're going to convert alcohol into aldehyde, then aldehyde into carboxylic acid, and over here we are using access, so definitely carboxylic acid is going to be formed, right? So what I just need to do, आप इसको same कर सकते हो पूरा. मैं क्या कर रहा हूँ, मैं कार्बन कार्बन डबल बॉन्ड लिख रहा हूँ, मैं H को चेंज नहीं कर रहा, मैं CH3 को चेंज नहीं कर रहा, मैं उस लंबी चेन को R लिख रहा हूँ. आप इसको पूरा लिख सकते हो, और जो CH2 था उसको मैंने कार्बोक्सिलिक एसिड बना दिया है. ठीक है ना? Can see that because we are using access. ठीक है? Then ethanoic acid is in the presence of acidic catalyst, definitely it is going to form what? Ester. So again, the carbon-carbon double bond is same, hydrogen is same, alkyl radical is same, CH3 is same. This is going to form what? This is going to form ester. So it will be COCH3. Right, bachcho? And then after that, they are saying hydrogen bromide. So definitely the double bond is going to be break. And on this carbon, we have hydrogen and bromine. अच्छा, इसके अंदर आपको वो भी देखना पड़ेगा मेजर और माइनर का सीन. तो मेजर और माइनर के सीन को अगर हम देखते हैं तो फिर उस हिसाब से आप ब्रोमीन और हाइड्रोजन लगा सकते हैं. और वैसे उसने मेजर और माइनर का यहाँ कहा नहीं है, तो जहां आपका दिल चाहे आप वहां पर भी लगा सकते हैं. तो एक तरफ CH3 मौजूद है, एक तरफ R की चेन मौजूद है, एक तरफ RH मौजूद है, और एक तरफ CH2OH मौजूद है. तो वो CH2OH जो है उसमें भी Br लगेगा, बिकॉज वी नो दैट वी हैव वन मोर रिएक्शन ऑफ अल्कोहल्स के अल्कोहल्स को अगर आप HBr कॉन्सेंट्रेट से रिएक्शन कराएं तो वो भी डिस्प्लेस होकर Br लगा देता है. तो इट इज ऑल्सो वन ऑफ द रिएक्शन ऑफ अल्कोहल. तो वो दोनों भी आपके पास आपको याद रखना है कि OH भी ब्रोमीन से डिस्प्लेस हो जाएगा, डबल बॉन्ड टूट कर भी H और Br लग जाएगा. तो उसने आपको अभी बताया नहीं है कि आपको मेजर या माइनर बनाना है, तो आपकी मर्जी, आप कहीं पर भी हाइड्रोजन लगाएं, कहीं पर भी ब्रोमीन लगाएं, और बस याद रखें कि OH भी डिस्प्लेस हो सकता है और Br लग सकता है. ठीक है भाई? तो ये तीनों जगह पर आपको लगाना होगा, तो आपको 4 मार्क्स मिलेंगे. आप देख सकते हैं कि 3 स्ट्रक्चर है और मार्क्स आपको 4 मिल रहे हैं. तो इसका मतलब ये हुआ कि फर्स्ट और सेकंड का आपके मार्क्स 1-1 मार्क्स है, और अगर थर्ड वाले स्ट्रक्चर के अंदर आप अगर H और Br अटैच कर देते हो और जो आपके पास OH था उससे सब्स्टिट्यूट नहीं करते हो तो 1 नंबर मिलेगा। अगर सब्स्टिट्यूट भी कर देते हो और H और Br भी अटैच कर देते हो तो फिर आपको पूरे 2 नंबर इस स्ट्रक्चर में मिल जाएंगे। इज दैट क्लियर एवरीवन ऑफ यू?